So here we go. Let's have another example for subnetting using vlsm. Now in this case, as you can see here, we have way more networks with a little bit more complicated case. So hopefully this one will stick if you had an issues with the first one. Now in the first example I made a couple of mispronunciations. For example, there was a number 16, but I kept calling it 26. So I apologize for that. Hope this time I'm going to try my best to not make those mistakes. So first thing first, we have this IP address with this same IP address we had before, but this time the prefix is 23. So when you convert everything to binary, you will get something like that. Now I want you to notice that the line that separates the network portion from the host portion is actually in the second octet to the right. So this is the first octet, this is the second octet. So we have the line here. So this is the dot that separates both octets, the first and the second one. Now, what we're going to do, we're simply going to start with the first IP address. And for the first IP address, we're going to have to ask ourselves, how many bits do we have to keep to be able to get the number of hosts as 110? And the answer for that is simply 7. So 2 to the power of 7 minus 2 is 126, and that's what we're going to do. So we're going to keep 7. Now, we know for sure that we have 8 bits here, so we're going to keep 7, so our line is simply this one. So what is that telling me? It's telling me that I'm going to be borrowing 2 bits from the host portion to the network portion. Okay, now with that being said, the thing that you have to pay attention here, which is very, very important, that those 2 bits, one of them is going to be from the first octet and the second one is going to be from the second octet. So since we're borrowing 2 bits, I want you to go ahead, I'm going to write them down here. 0.0, those are the possibilities, 0.1, 1.0, and 1.1. So since we're borrowing 2 bits, I can easily come here and put those 2 bits as 1 for the subnet mask, which simply means I'm going to add 2 to the 23, I'm going to get 25. So that's the prefix for network A. Oh, sorry, so let's put it here. Network A is going to have a prefix of 25. Now, with that being said, since we're using the first one for network A, so we're going to keep those 2 here as zeros. So I'm going to get an IP address of 192.168.96.0. Now for the second IP address, we're simply going to be using this one. So I'm going to be replacing those 00 with 01. Now since I have 100 hosts, that simply means I have no options or no choice but to use the 7 of them. So I'm going to use all of them. I cannot break this further. I'm going to be using the whole thing because I need to keep 7 to be able to get 100. So network B is simply going to be 192.168.96.128 with a prefix of 25. Remember here, I'm using 01, so this is 01, and we convert this to decimal, you get 128. Now remember here, what we do, we start with the first IP address, and we ask ourselves, how many bits do I have to keep to be able to get 110? And then I move to the second IP address, and I ask myself, can I subnet the second IP address further to be able to get 100? And the answer will be no. You have to use 7 of them, and that's why I did. I used 7 of them. Now for the third one, he wants 60. This is a case where I can actually subnet. So what I'm going to do, I'm going to come here in this area here and put it as following. 1.0, remember, I'm talking about this area here, and I get 1, 2, 3, 4, 5, 6, 7. So here, 1, 2, 3, 4, 1, 2, 3. That's 8. Remember, this is my original line. This is my new line. And we're talking about C in this case. Very, very important. Now, I ask myself, I need to get 60. Now, remember here, we're using this IP address, and now I am at 60. How many of those 7 IP addresses, bits that I have, do I have to keep to be able to get 60? And the answer is 5. So I am simply going to keep 6 bits, 6, not 5. And that simply means it's going to give me 1 bit extra to be borrowed. So my prefix in this case is going to be 26. You know what, will just make more sense if I go with 26. And I got 1 bit to borrow, so that 1 bit could be 0, it could be 1. Now, I'm going to go with 0. For 0, I'm going to use for C, so I'm going to come here and put it as 192, 168. Now remember here, really, really important. This is my IP address. I need to convert this IP address. Remember here, we have a bunch more of values, but I'm focused on this one. For this part here, that's going to be a simple 0. So I'm going to put here as 0. But for this one, look, this is 1. So this bit that you see here is 1. So you add it to the 96, it will make it 97. Okay? So because I'm using this bit, so it's going to simply mean 1, 0, and the rest are going to be zeros. So because this is 1, it's not 0 anymore, you convert this number to decimal, you get 97. Now, we're done with this IP address. Now we're still working on this one here, but we use 0 and now we can use 1. So this basically will be 1 for the second case. And we're going to ask ourselves, for 50, how many bits out of those 5 do I have to keep to be able to get 50? And the answer will be all of them. So I'm going to come here and put D, 192, 168. Remember here, this is still 97. And this one, instead of having it as 0, remember here, 0, 1, 0, 0, 0, 0, 0, and that is 64, and the prefix is still 26. Now that I'm done with this case, so I covered this case, simply means I covered the whole case that I have here. I need to go to 30, but my only left option is this one. Now what I'm going to do, I'm going to put the IP address as it is because I'm going to play a little bit or play a lot with this IP address. So I'm going to put it down here. Now remember here, instead of me writing the whole IP address here, I am just going to write down the area where I'm going to be playing. So I'm going to have 1.1, and this is my line, and this is my line, and then I got 7 zeros. 1, 2, 3, 4, 5, 6, 7. Now, this IP address that I have here, I am going to be using it to subnet everything that I have here. So, since that's the case, let's go ahead and ask ourselves the following questions. How many bits do I have to keep out of those 7, pay attention to the 7, to be able to get 20? Well, the answer will be 5. Okay? The answer will be 5. So if I draw the line for the 5, here they are, that simply means I will have 2 bits to borrow. So if I want to put the subnet mask was 1.1, and now I'm borrowing 2, so that will make it 1, 1, and the rest are going to be simply zeros. This is the subnet mask. Well, but we were more concerned about the IP address. So let's go ahead and look at those possibilities. Now, before I jump into this IP address and how do I subnet it, I am simply going to put it in a form of an IP address. That will be 192, 168, 97.128. And since I'm borrowing 2 bits, before I borrow any bits, the actual subnet mask for this case is 25 before we borrow. It's 25 because we're talking about this situation here. Okay, now we're borrowing 2 bits. Let's go ahead and put the possibilities. Those possibilities are 0, 0 for those 2, 0, 1, 1, 0, and 1, 1. And let's go ahead and I'm going to cut it actually from here. Oh, this is going to stink a little bit. I'll just take it as it is. Okay. Cut it from here. Control V. I'm just going to move it here. And let me do a little bit of cleaning because I don't really need the subnet mask. Okay. So here we go. Those are the possibilities. 0, 0, 0. Now what we're going to do, we're going to start with network F. Oh, wait a minute. A, B, C, D. A, B. Oh, did I make a mistake? Did I skip something? So this is for A. This is for B. This is for C and D. C and D. And now we're talking about Oh, wait, yeah, yeah. Sorry, I forgot about this. So we're talking about those 30 and 20 and 10 and 5. Okay, I looked at 20 before, but I was supposed to be looking at 30. But the idea here is going to be the same thing. 20 or 30, you need to you need to keep 2 bits. Okay, that was like, let me just write a line here, just draw a line. So I know that I already completed this part and we're working on this part. Now remember here, when I was answering, like a few minutes away, I start talking about 2. I forgot about 30. But again, I need to go back to 30 because I haven't done anything to it. But because this is 30 and this is 20, and both of them simply will require 5 bits, so simply I didn't make a big mistake here. So we're just going to have to focus on 30 first. So let's go ahead and put E here. And we said we're going to be borrowing 5 bits, keeping 5 bits, we're going to borrowing 2. So originally we had 25 when we borrowed those 2. And now we're borrowing 2 more, so it's going to make it 28, sorry. Well, wait a minute. Let me just go back here. This is my original 25, 26, 27. Yep, 27. Okay, now, all we have to do is just ask ourselves, we're going to choose, for example, 0, 0 at the beginning, so that's going to make it 192, 168, 97, dot. Remember here, this is 128. The second one, we're going to use it for 20. Now, for the second one, if I put 1 here, that's what I'm doing, and I have to ask myself, how many bits out of those 5 I have to keep to be able to get 20 hosts? The answer will be the same thing, 5 of them, so that will make it F to be 192, 168, 97, and the prefix is 27. And now for this part here, this is 128 plus 32. So this is 061. So 160. I hope I didn't make any mistake. Yes, I didn't. Okay, so we covered 30 and 20. Let me just take out what I have here. I don't need that anymore. And let's go back here. So we're going to move on to this one here. And for that one, what I'm going to do, I'm going to put it here. So it will be clear. So it's going to be 1, 0. That's the third one. And we're going to be talking about 10. Now for 10, before I continue and do anything, I have to ask myself this question. How many bits out of those 5 do I have to keep to be able to get 10? And the answer will be 4. So I am going to have to borrow 1 extra. So this is the extra. Remember here, we're talking about this one. This is what we're working on. And we're borrowing 1 bit. So because we're borrowing 1 bit, this bit could be 0 and could be 1. So we're going to go with 0 first. And 0 is going to be used for 10. So I'm going to come here and put G. And remember here, this is 0. So it's going to be 192, 168, 97, dot. Now remember, since we are using 0, and this is 110000, that's 192. But the prefix, since we're borrowing 1 extra, it will make it 28. Now, for 5, I am simply going to go ahead and use 1 instead of 0. So I'm going to put 1 here. So we covered this one, and now we're covering this one. And this is going to be for H. And remember here, we're still working on the 1, 0. Now, since we're using H, we're talking about H here, and H requires 5. And remember here, for the 10 that I had here, I have to keep 4. But for the 5, I have to keep 3. Look how crazy it's getting. So I'm going to borrow 1 extra. Now remember, we covered this case. We covered this. We were still in the process of covering this case here. And for the 5, we had to borrow 1. So it's all about this one here. That one could be 0 or could be 1. And since I'm borrowing 1 extra bit, so this is going to make it 29. So let's go ahead and put that as a 29. And since there are 2 possibilities, 0 and 1, remember here, we're still at this level here. So we're going to go with 0. And because we're moving with 0, it's going to be 192, 168, 97. Now remember here, this by itself, this is 128. Where are we? Yeah, here it is. 192, because we're using those two, plus whatever we have here. Plus whatever we have here. So previously it was 0, and we moved to 1, and now we're putting this as 0. So it's going to be 192 plus 1, 2, 4, 8, plus 16. Let me make sure. No, that's not 16. Yes, it is 16. 1, 2, 4, 8, 16, 32. Yep, 16. That will make it 8, 0, 2. I hope I'm not making any mistakes. Let me just make sure. 6, 1, 2. So that will make it 2, 0, 8. And we covered 5. Now the last option here, we have the last network, which is 2. And for the 2, we're simply going to put this as 1, because we're using this IP address now. And after I'm done with that, I can say that I'm done with this part. I'm still having this part that it didn't cover, which is, again, I really don't need it. So how many out of those 2 bits, 3 bits that I have to keep to get to is simply going to be borrowing 1 extra bit. Since I'm borrowing 1 extra bit, this is going to make it 30. And this is, again, I. So it's going to be 192, 168, 97, dot. Now, since I'm borrowing, again, 1 extra bit for this one, and I'm using, as I said, I have 2 options for this one here. It could be 0 or could be 1. I'm using 0 for simplicity. So this is it. And all I have to do now is to convert this number here to decimal again. So I'm just going to put it here. This is 1, 1, 0, 1, 1, and 3 zeros. I'm converting this number here to decimal. And that value is 192. Well, we added to it 16 before. It gives me 28. And now I'm adding 8 to it. So it's going to make it 216. So this is going to be simply 216. And I am done. Now, at this point, I am going to go ahead and try to verify that I got the answer correctly, which I already tried it on this. Wait a minute. Let me just drag it. Here it is. So let's go ahead and compare it. This is A, 96.0, 96, 128, 25, and then 97, 26, 97, 64, 26, and then 97, wait a minute. This is 9764. Here it is. Yeah, 1964. 26. Yep. 97, 128, 27. Here it is. 97, 160, 27. Here it is. 97, 160. We got that. 97, 192 with a 28 prefix, and then 97, 208 with 29, and then finally 97, 216 with 30. And here we go. You got it right. I can tell, even though I'm not seeing any of your faces, that this method may not be your favorite method. And that's totally okay. I totally understand that. But this is, again, if you go deep down how exactly this is done in a machine, for example, logically, this is how it's done. And as I said, just like how we did it previously, I am going to go ahead and repeat the same process, the same issue. But this time, we're going to use the different method with that mask that we talked about before. So let me just move it down. You know what? Let me just put it here. Now I need to clean a little bit. Let me take this one away. Let me clean this part as well. Let me clean this part. I don't need this one here. Okay. So if you didn't understand this technique from the previous example, this is your chance to know how exactly we're going to do it. So before I jump into anything, as I said, for each one of those IP addresses, for each one of those networks, I need to add 2 hosts to those number of hosts, and then I have to round it up to the closest value out of those sequence that I'm going to write down. 1, 2, 4, 8, what is it here? 16, 32, 64, 128. Okay? Okay, so for the 100, we're going to add to the 100. 2 is going to make it 100. Sorry, 110, we're going to add 2 is going to 128, 112. That simply means it's going to be 128. Same thing here, 128. This is 62. That will make it 64. Let me just put an arrow here so we don't miss. 52, 64 again. 30 is going to make it 32. 20 is going to be 32. Oh, wait a minute, 32. And then 10 is going to make it 16 because 12. This is going to be 8. And this is going to be 4. Okay, so these are the numbers that we're going to use when we're going to create that mask. I'm going to start by doing the following. I'm going to take the IP address. Let's start with the mask 0.0.0, and this is going to make it 192, 168, 96.0. Now, the first thing we need to figure out, what will be the prefix for the first network. As I said before, you have to ask yourself, 2 to the power of something is going to give me 128. What is that something? And the answer is 7. So what I'm going to take, I'm going to say 32 minus 23, and that is 9, I believe. Let me just do it. My brain is just simply calculator. So what is it? 32 minus 23, and that's 9, just like I said. So that will give me 9. Now I'm going to subtract 7 from the 9, which is going to give me 2. So you take the 2, you add it to the 23, you get 25, and that's your subnet mask. So I'm going to come here and put A, and I know the subnet mask is simply going to be 25. Now, with that being said, let's go ahead and try to figure out what will be the IP address itself. As I said, we're simply just going to add whatever the value that you have here to the IP address, which is simply going to give me the same thing, 192, 168, 96.0. Let's move on to B. Now, since B has the same 128, so the prefix is going to be the same, so it's going to make it 25. But I have to just add 125 to the mask, so I'm going to end up 128. So you add that here, you're simply going to get 192, 168, 96, and then when you add those together, you get 128. Now that we're done with that part, let's move on to, we simply added this one. We're going to move on to the third one. For the third one, remember here, we got 64. So 2 to the power of something equals 64, and that something is simply, in this case, 6. So we're going to come here and do the same thing. 32 minus 23, which is 9. 9 minus 6, that is 3. So you take the 3, you add it to the 23, it's going to give you the IP address subnet mask, so that's going to make it 26. And that's for C. Now what I'm going to do, I'm going to take the 128 and I'm going to add it here to this 128. And that will give me 256. Now, whenever you get a case of 256 or more, you probably will never get more, but if you get more, you simply have to set it to 0 and add 1 here. Whatever the value that you have here, just add 1 to it. So this is my new mask. Just add it here, you will get the value 192, 168, 97.0. And that's for network C. Now, with that being said, that simply means I already covered this network IP address. I added this IP address. Let's move on to D. For D, since it's 50, so it's going to be the same prefix. So let's make this one 26. And all I have to do is to add 64 here. So we add 64 here. And that will be my mask value. So 192, 168, 97.64. And that's me covering those two cases. And now I added 64. Let's move on to this network E. Network E has 32 bits. And since they have 32 bits, we're going to have to figure out a new subnet mask. Same thing, 2 to the power of something should equal 32. And that something is 5. Now, 32 minus 23, which is 9. 5 minus 9, that will make it 4. Take 4, add it to the 23, that will make it 27. So I'll get 27 here. And let me move down a little bit if that's possible. I need to drag it a little bit. Okay, we have some extra space. So we're talking about 30 at this point. Now, so that's 27, and let's just put E here. Now the question is, we got 64 here, and now we have to add another 64 to the value that we have here, and that will produce 128. So come here and put 128. You add them up together, and you will get a new value. Let me just cut this from here and put it down so I can see it next time I'm doing the calculation. Okay, so here we go. This is the value. Add them together, get 192, 168, 97.128, and now we covered case of 30. Now remember, the last value we added was 64. Now we're moving to the case of 20. Now case of 20, we said is simply going to be the same prefix. So this is F. And now we're going to add to the 128, we're going to add the 32. So when you add 32 to 128, this is going to be 0, this is going to be 6, this is going to be 1, so 160. Do we have 160 above? Yeah, here it is. We do have it. I just wanted to make sure. So we are going to end up having this to be 160. 160, and let me clean this mess here. Nope. I need a Photoshop application. So here we go. 192, 168, 97, 160. I'm going to use the rest of the space here for the rest network. So what did we cover so far? We covered F, and we added 30 from here. Now we're going to go to G. Now remember, the last value we added was 32. Now we're moving to G. For G, remember here, this is 2 to the power of something should equal 16, and that something is simply 4. So 32 minus 23, that is 9, and 9 minus 4, that's 5. You take the 5, you add it to the 23, it's going to give you 28. So the prefix here is going to be 28. And what do we do after that? We take the value that we have here. The last value we added was a 32, so we have to add another 32, and that will make it 192. Yep. So this is going to be 192. I'm going to go ahead and put 192, 168, 96. Oh, sorry, 97. My bad. 97. 192, and now I cover 10, and I added the 32. So we can move on to H. Now from H, because I need 3, so because I have 8 here, that simply means I will have the value here to be, let's just put 8, that will lead to the value is going to be 3. 9 minus 3 is 6. 6 plus 23, 29, so the prefix is going to be 29. And now what are we going to do? We're simply going to take this away. The 192 is going to be, we're going to add 16 to 192. So if I come here and say 192 plus 16, this is 8, this is 0, this is 2, 208. Let me take this away. And yeah, let me just erase this. 208. 208, and this is 192, 168, 97, 208, and I added 16, so I'm done. The last part is the 2, the network I. Now, to be able to get 4, this time this is going to be 2. You need 2. And remember here, let me just clear it. 2 to the power of something should equal 4, and that simply means 2, and then 9 minus 2 is simply 7. 9 minus 2 is 7. 7 plus 23, that is 30, and I'm done with the prefix. So what I have to do here, I need to add 8 to the value that I have here. So I'm going to end up having 216. And you add them together, you get 192, 168, 97, 216, and I believe this is exactly the same result that we got from the previous example here. 025, 025. Let's just say 96, 025, 96, 025, 96, 28, 25, 128, 928. Okay. 97, 026, 97, 026, 97, 64, 26, 97, 64, 26, and then 97, 128, 27, 97, 128, 27, 97, 60, 27, 97, 60, 27, and for the G, 97, 192, 28, 97, 192, 28, H, 97, 208, 29, 29, then 97, 216, and 30, and everything is matching. So here we go. You got 2 examples of VLCM. I hope this will be the end of this series of subnetting and networking calculation classes. I hope you guys find this helpful somehow. And if you have any questions, just let me know. Thanks you again for watching, and I'll see you guys later.